So let's take a look at a couple of examples. We'll start with an easy one and go to a little bit more complicated one. So we're looking to find the surface area, and let's go do a cylinder as our first example, and I'll add some dimensions onto the cylinder. And so let's calculate that surface area. We can use the formula. Please, if you're going to use a formula, state the formula. If you are approaching it with another method, like adding up all the faces, label the faces, then put the formulas in and add them all up afterwards. Show all the calculations as you go along, and keep your work really organized. That way, whoever's marking it will be able to follow your work. You're communicating your mathematics really well, clearly. So I'm going to do that by putting down my formula, 2 pi r squareds, that's the top circle and the bottom circle, and 2 pi r is the circumference times the height, that's that label side. And then I'm going to start substituting. So my radius is half of the top, so that's 4 getting squared, and 4, and the height of this cylinder is 10. And I'm going to do something kind of interesting with this, and some people have mentioned this in class over the years, and it's really helpful, I find, to do this step. But basically, we're going to treat pi like it's its own number variable, and I'm not going to go grab a calculator to calculate what pi is worth and multiply it yet. And you'll see there's a big advantage to this, aside from not having to use my calculator. So let me work through this. 4 squared is 16, and then 16 times 2 is 32 times pi. And over here I have 4 times 10, which is 40, times 2, which is 80 pi. So 80 times pi and 32 times pi, and you can actually just add those up. So 80 pi's and 32 pi's is quite a few pi's. Let's see, 112 pi's. And since this is centimeters, and surface area is always just like area and square units, you can write in the units afterwards, and you have an exact answer. If you then, and I didn't need a calculator to get that exact answer, if you then wanted to use a calculator, or needed to if the question said round to 2 decimal places, then you can go and punch in 112 times pi, or just 112 pi on those calculators, and you can get 351.86 centimeters squared. And that's an estimate of the answer. The other advantage with doing it this way is a lot of students that I've seen have calculated back up here at one of these steps and written down some of the decimals, but they don't know how many decimals to write down. It's actually an infinite number of decimals, and then maybe when you go and calculate the addition part, you don't get exactly 351.86 as your estimate. You get 0.85 or 0.87 or something else because you've rounded and then rounded again. With this method, we don't do those calculations and those roundings until we do that last step of just 112 pi, which is the exact answer, as an estimate. Alright, let's take a look at another example. This one is perhaps a little more confusing. So again, we're going to find the surface area, and it's going to be a bit more of a complicated shape. We're going to start with what looks like a rectangular prism or a box on the bottom, and we are going to create, kind of looks like a bit of a smokestack on the top here. So a shape that looks like this, and we'll give that shape some dimensions as well. Now at this point, I really encourage you to not immediately jump to looking for a formula that's going to work. Instead, stop, think, and work through the problem slowly, not relying on a formula. So we do want to calculate the surface area. Let's use the method that we've used before, where we start to look for similar sides and label them. So the front could be an area 1. The back of it would also be an area 1, so I would have 2 area 1s. The right hand side could be an area 2, and so could be the left hand side, so I have 2 area 2s. The bottom could be an area 3, Now, here's an interesting thing. If you were flying over top of this object and you looked straight down onto the top of the object, this is what you would see. And if you took that whole area, including that circle, and you painted it, you would have a total area exactly the same as the bottom. So this shaded part on the top, and be careful, I'm shading that part and that part. The total of both of those faces is exactly the same as area 3. So instead of breaking this object apart, I'm going to compose it together. I have an area 3 on the bottom, and together both of these pieces would make another area 3. So I have two area 3s. Now the only part that I'm missing is the little label on the side, and we have a formula for that little label. We'll call it area 4 right now, and we'll be able to calculate that separately. So let's go ahead and do some of this. Area 1 is 10 centimeters by 4 centimeters high. There's two area 2s. They are 5 centimeters by 4 centimeters. There's two area 3s. The easiest one to think about is the one on the bottom, which is 10 by 5. And there's an area 4. And area 4 is the side of a cylinder, and the side part of the cylinder had to do with pi. It was 2 pi r as the circumference times height. So I just want to know 2 times pi times r times the height to get the area 4 part. So again, I put all the formula out. That was my step number 1. Then I substituted in some numbers. There's my step number 2. If I want to, I could substitute in this radius and this height right now. So the radius of that is just 1 centimeter because the total distance is 2, and the height is 3. Now I go and crunch some numbers. And like I did in the last one, I could just crunch each little bit. So 40 times 2 is 80, and 20 times 2 is 40, and 50 times 2 is 100. And leaving the pi's in this one, 3 times 1 is 3. Times 2 is 6 pi's. Then 80 and 40 and 100 is 220, and 6 times whatever pi is worth. And the units again is centimeters squared. This would be the exact value. And I could grab the calculator to get the estimate. So my third step here was I did some calculations. I kind of brought together some like terms. If I need to do an estimation of an answer, I did an estimation of an answer. Make sure you stop, think, and don't rely on formulas. Working through with mathematical mind, thinking through which sides are the same, which ones are different, definitely will help you keep organized. You should be able to do one of these questions nice and organized in about the amount of space that you see that I use here, and I should be able to follow your work fluently. Each step should be equal to the surface area if there's equal signs showing that it's surface area, rather than random numbers all over the page and then added together at the end. Okay, we'll definitely get to practice this in class, and some of the questions in this section do get a little bit tricky, so we'll get lots of practice on it. All right.